So, number 11 is our piecewise functions, and this is a new skill, so this is one that I expect you had a little bit of trouble with when you were first getting started. And the idea behind it is this. In the real world, most of our equations will be what's called piecewise, and what that means is one formula is not enough to describe the entire situation. Rather, it'll be made of pieces. So as an example, you might consider someone who is traveling away from home. They stay at the park and then they come back home, right? You've got pieces. You've got the part where they're traveling away from home. That could be distance from home. This could be time. While they're at the park, it stays level and then they come back. You could have a situation where one part of the graph behaves in a linear fashion and then the second part of the graph behaves as an exponential curve. And you would have these two distinct pieces split at this point. That's the idea behind the piecewise graph. One function is not enough to describe the whole thing. So when I come up here, and we're going to look at part A first, obviously, I want to graph these parts. Now, for a very good reason, I'm going to start for the second one. And the reason I'm going to start there is because I think this is a function we're much more familiar with, x minus 2. If I wanted to graph that line, that's telling me that I'm going to start at negative 2. I've got a positive x. So I can plot all those dots right there. And my hope is roughly looking at those dots, you see the line formed by x minus 2. Here's the deal though, I don't get to keep the dots everywhere. I only get to keep the dots from negative 2 to positive 2. So what I'm going to do is I'm going to start at negative 2. And at negative 2, I'm going to come down to my graph. And what I'm going to do at this point is, because there's no bar underneath my inequality, it's going to get an open circle. In fact, I'm going to do this one red. And then I'm going to go over to positive 2. And when I plug positive 2 in, it's right here. That also gets an open circle. Again, because there's no bar underneath my inequality. I can then draw in that line. So the idea is I've drawn the entire line x minus 2. This is the line x minus 2, but I've only kept the parts between the x values that I want, from negative 2 to positive 2. Those are the only x values that I want, and the rest of my line doesn't exist. And that would be this second equation right there. I can do the same thing with that third part. My line is changed now. It's now negative 2x plus 4. So I would start up here at 4, and I would go down to every time. Same idea, hopefully you can kind of see where those dots are. But now my inequality says x is greater than or equal to 2. I've got an equal to. So when it starts at 2, it's going to get a closed dot. It's filled in. And that graph is going to continue for all the x's that are bigger than 2. So 3 is bigger than 2, 4 is bigger than 2, 6 is bigger than 2, and so on. And that would be that entire graph portion. I chose to do those two first, because when I jump up here to negative 4, I know a lot of you have questions of, what x's do I plug in? Where does this go? Here's what I want you to think about. No matter what x I tell you, 5, the function is going to give me back negative 4. If I plug in 10, it gives me back negative 4. If I plug in negative 100, it gives me back negative 4. So in other words, x doesn't matter. And I have a constant output of negative 4. That is to say, that starting here at x equals negative 2, my output is negative 4 with a closed dot. And I'm going to have the horizontal line going to the left, because no matter what y value you tell me, I always have an output of -4. When there's no x value on that function, you have a horizontal line. The inequality with the equal to underneath the single bar tells me that's going to be a closed dot on the black part, and I want everything to the left because I want the number smaller than -2. I'm going to jump over here to B. Same thing, I've got parts here. The first part says 3x plus 12. This is going to be kind of hard to see. Let's see, plus 12. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's only 10. So that means 11, 12, and then that would be 9. And then I need to go down 3 each time. So all of those dots right there would be my 3x plus 12. But now my graph says, guess what? I only want the ones that are less than or equal to -3. So I'm going to come over here to -3. 1, 2, 3, that's -3. I'm going to find my graph. It's an equal to, so it gets a closed dot. And I want x's smaller than -3. So I'm going to take all my x's to the left-hand side. And that's the first part of my graph. I'm going to jump to my second equation, which says absolute value of x. So that's going to start here at 0, 0. And I've got single dots going in both directions, because that is my absolute value shape. You can see those dots in pencil right there. But now it says that I only want the ones from -3 to +3. There's no bars underneath, so they're both open circles. So I go to -3, open circle. I go to +3, 1, 2, 3, open circle. I'm going to connect my dots, and that's the middle part of my graph. Finally, I jump to the last part, which says -3x plus 12. So I'm going to start at 12, I'm going to go down 3 each time. Okay, so you can see that string of dots right there. I know it's kind of faint, but that is my line, -3x plus 12. But now I'm only interested in the ones that are x bigger than or equal to 3. So when I go to 3, 1, 2, 3, I go up to my dot. Bar underneath means equal to, it gets a closed dot. I want the values that are bigger than 3. Those are going to be the x values bigger than 3, because that's x is 3, x is 4, x is 5, x is 6, and so on. And that will be my final piecewise graph.